Geometry 1, Chapter 6 Test, Topic 3. You should be able to distinguish between a circumcenter, incenter, centroid, and orthocenter, and identify lengths based on the picture. So the first example, B, D, and F are midpoints. AF equals 5, CA equals 14, GF equals 6, ED equals 8, AG equals 7. Find the following information regarding the triangle. So there's quite a bit of information going on here. First of all, they tell us that B, D, and F are midpoints. So it's a pretty important part because first of all, what that means is that, for example, F right here is halfway between E and A, which means these two pieces are congruent. Also means a similar thing for AB being congruent to BG and ED being congruent to DC. So we have lots of congruencies here. It also tells us what our picture is, because now this line from F to G, notice it goes through the midpoint, which means it's a bisector. It's also 90 degrees, which means it's the perpendicular bisector. So this picture is of perpendicular bisectors. And why that's important is that perpendicular bisectors come together at point G right here, and that is called the circumcenter. The point of concurrency, or the point where the perpendicular bisectors intersect, is called the circumcenter. Now it's my advice that we go ahead and put some of these numbers on our picture. So for example, AF is 5, and CA is 14. That's this whole piece over here. GF is 6, ED is 8, and AG is 7. Now notice AG is not technically drawn on the picture, but it's that length right there. Okay, so let's see here. The distance from A to E, the length from A to E. A to E is the whole distance here. Well, AF is 5, which means EF is also 5, so the whole distance is 5 plus 5, 10. We're also asked for AB. Now notice from A to C is 14, and the two pieces are congruent, so 14 divided by 2 is 7, which means both of these, AB is 7, and so is CB, which is the top right question. We also need DC. If ED is 8, DC is congruent, so that's also 8. EG and CG. Now notice EG is from the vertex to the circumcenter, and CG is also from the vertex to the circumcenter. Now one of the special things about the circumcenter is that it is equidistant to all three vertices. So the distance from G to A, E, and C are all the same. Since AG is 7, EG is also 7, and CG is also 7. All a distance of 7. So the perpendicular bisectors create the circumcenter, and the circumcenter is equidistant to the three corners, the three vertices of the triangle. The second picture. We have some measures here. The measure of angle EDK is 32 degrees. The measure of angle AGD is 96 degrees. KF equals 2 and KC equals 5. Find the following information regarding the triangle. So here, one thing to note is what this is a picture of. We do have 90-degree marks there, but look in the angles. We have two congruent angles here, two more congruent over here on the bottom, and two more congruent on the left side. What that means is that we have angle bisectors. And if we have angle bisectors, the point where they come together, K, is called the incenter. So let's fill in the measurements that we know. The measure of angle EDK. EDK is 32 degrees. That's right there. The measure of angle AGD is 96. That's this whole angle right here. The whole angle, both of those together. KF is 2 and KC is 5. Okay, let's continue now. The measure of angle CDK. CDK is congruent to EDK. They both have one arc, so that's 32 degrees. The measure of angle CDE. Now notice CDE is this entire big angle over here, CDE. So that's 32 plus 32, which is 64 degrees. HGK, the measure of angle HGK. HGK. Now HGK is only the left half of angle HGF. HGF is 96 degrees. It needs broken into two equal pieces. So that's 96 divided by 2. .48 degrees. The measure of angle FGK. FGK, that's the right side. Notice the right side and the left side are congruent, so they should both be 48 degrees. The measure of angle JAB. Now this one's a little trickier because what we have is essentially no information given to us about that third corner of the triangle. So we have to use some information from before. For example, what do you know about the three angles of a triangle? Well, they need to add to 180. And what we have is a picture, looks kind of like this, where this angle down here is 96 degrees. The angle up here, we already determined CDE was 64 degrees. And we can actually find the third angle. 96 plus 64 is 160. So 180 minus 160 is 20. We know that this angle up here, JAB, the big angle, needs to be 20 degrees. And what that means is the measure of angle BAK, just the small angle, half of it, would be half of 20, which is 10 degrees. Now the part of this question that is missing that is also fairly important are the distances, the lengths, KH and KB. Because the incenter has a very special property, and the property that it has is that it is equidistant to the sides of the triangle. That is, the distance from K to the three sides are all the same. So the question becomes, it's either 2 or 5. Which one is the distance to the side? So distance is measured with the shortest line, that is the perpendicular line. And notice H and B also are 90 degrees, which is kind of an indicator we won't need to use the distance to F. So KH is 2 and KB is also 2. Two more important questions to be able to answer about the incenter. Now the third one. B, D, and F are all midpoints. AG is 15, CA is 20, GB is 4, CD is 14, and CF is 30. Find the following information regarding the triangle. So this one's a little more complicated because we have midpoints again, which means, let's see here, AF is congruent to EF, ED is congruent to DC, CB is congruent to AB, which makes some of our lengths fairly easy, but notice the perpendicular lines are not the lines that are crossing. Point G is the line, or is created by the lines that go from the midpoint to the vertex. Midpoint to vertex. That's very important. The point of concurrency here, this line going from the midpoint to the vertex is called the median, and the point where they cross, the three medians, the point of concurrency, is called the centroid. The centroid is fairly easy to identify because you do have the perpendicular bisectors, but it is the picture that goes to the vertex from the midpoint. So let's see here. Some lengths. AG is 15. CA is 20. GB is 4. CD is 14. And CF is 30. Now CF is the only one that's not very convenient to put on our picture, so I'm just going to leave that one off for now and kind of mark it as not being in the picture yet. So let's see here, DG. Now a special relationship in this picture is that notice AG is longer than DG. EG is longer than BG, and CG is longer than FG. The relationship here is the distance between one vertex and the centroid is twice the distance between the centroid and the midpoint. So this distance is going to be twice this distance. AG is going to be twice DG. So how do we find DG? We take AG and divide it by 2. 15 divided by 2, 7.5. Now AD, the full distance, would be AG plus DG, the segment addition postulate. So that's 15 plus 7.5. 22.5. All right, CB. Well, CB is very, very similar to the first example of this section. A to C is 20. We know it's divided into two congruent pieces. So 20 divided by 2, they have to be 10 and 10. So CB is 10. AB is the next question. It also needs to be 10. Now what about from E to G? Now notice E to G is the longer piece of this line segment. So E to G is going to be twice the distance from B to G. So that's 4 times 2, which is 8, which means E to B is 8 plus 4 for 12. Now ED. ED is down here, is congruent to CD, so they both have to be 14, which means E to C, the whole distance, 14 plus 14, a total distance of 28. Now CG and FG. This one's the tricky one. Because notice, they gave us CF is 30. But now we need to divide it so that we have two pieces that are not equal, but where one of them is twice the other. So one way to go about this, and there are several ways, the one I prefer is to take the total distance, 30, and divide it by 3, and you get 10. Now what that means is that the shorter piece is 10, that's F to G, which means the longer piece, C to G, is twice the shorter piece. 10 times 2 gives us a length of 20. So the centroid, it's important to remember that one of the pieces is twice the distance of the other. Now the last one, identify the following point of concurrency. This one's a little less exciting. Notice there aren't any questions over here on the right because the measurements aren't as easy to do. There's not as much going on with this picture, but we do need to acknowledge what it is a picture of. So things to note. Right here, the lines are perpendicular. All three of them are perpendicular. And the perpendicular line goes through the vertices. So this is perpendicular and through a vertex. Well, if you have a line that is perpendicular and it goes through the vertex, that is called an altitude. So the three lines are called altitudes. So we have 3 altitudes, and the place where the altitudes cross or are concurrent is called the orthocenter. So again, the circumcenter is where the perpendicular bisectors cross. You'll notice that because it's perpendicular and through a midpoint. The incenter is where the angle bisectors cross. You'll notice that because of the congruent angles. If you have a picture like this one, where it's perpendicular, a midpoint, but then it connects to the vertex, instead of the lines, the perpendicular lines themselves, that's called the centroid. And the altitudes, perpendicular through a vertex, cross to create the orthocenter.